Oh, hey there. Welcome DC-CAS strategies. Nothing else would I love more than sitting down reading a nice book after a long day's work. But hey, why don't you come over here? We're going to be talking a little bit about Pythagorean Theorem today. So, first things first, we need to start off with a little bit of vocabulary. So we're going to hit two things today: hypotenuse, Pythagorean theorem. You've heard both of these before. I bet you're very well practiced with these, but we're just going to do a little bit of review. So the hypotenuse is always going to be the side of a triangle that is across from a 90-degree angle. So if we have a right triangle here, okay, the hypotenuse is always the side that's right across from that 90-degree angle. Typically, we usually see that as C, but it could be any letter, okay? So the whole thing that we're going to be working with today are different forms of the Pythagorean theorem. And it all comes down to looking at a triangle, okay? It could be rotated any which way. Here I flipped it over here, but it's always going to be working with a right triangle, okay? And basically, it gives us a relationship between the sides of a triangle and the hypotenuse, which is, again, is always just right across from the right angle. So our Pythagorean theorem is a squared plus b squared is equal to c squared. Okay, so typically in these problems, whether it be word problems or just picture problems, you're going to get two pieces of information. You're going to know maybe two sides and you'll have to solve for c, or maybe you'll know one side and the hypotenuse, and you're going to have to solve for the other missing side. So let's do a couple practice problems. So first up, two flavors of pictures. Okay, first one's real straightforward. You guys will be excellent at this. This is our mildest version. Okay, so you're looking at a triangle. All right, we have two sides here, and I noticed that the missing side that I don't know the number of yet is across from my right angle. This is, you got it, my hypotenuse. Okay, so we're just going to use our Pythagorean theorem here, and we're just going to plug in. Okay, you know what? 3 could be my A or 3 could be my B. It doesn't really matter. Okay, but let's just say we do 3 squared plus 4 squared is equal to c squared, because c is what we're missing. So 3 squared, 9 plus 4 squared is 16. That equals c squared. 9 plus 16 is 25 is equal to c squared. Okay? And then to undo that squared, I need to take the square root of both sides. So I'm going to take the square root of 25 and the square root of c squared, and I get 5 is equal to c. So I know c is really a length of 5. Notice how the hypotenuse is the longest side of our triangle because it's across from the biggest angle. Okay? The shortest side in a triangle is always going to be across from the smallest angle in it. Okay? So, B. Alright? This one's a little bit tougher, a little bit trickier. They're throwing in some decimals here. They're trying to confuse us. Alright? But it's the same darn thing. Okay? We need to solve for side A, but notice we know our hypotenuse. Okay? So let's just plug it into our formula. So I have a squared, that's my missing side, plus 4.2 altogether squared is equal to 8.5 squared. Okay, let's pull out our calculators. And I got 4.2 squared, 17.64. So a squared plus 17.64. That's equal to 8.5 squared. So plug that in as well. I get 72.25. Okay? I'm trying to figure out what A is, so I got to get rid of my 17.64 on both sides. Boom, boom. This will cancel. I get A squared is equal to 72.25 minus 17.64. That gets me a 54.61. Don't stop there. That's what A squared is. Okay? We got to finish off our solution by taking the square root. So I take the square root of both sides. Boom, boom, boom. I got A is equal to 7.389857915. We're going to round that to the tenths place. 7.4. So my side A is 7.4. Alright, one more flavor. Okay, we got our two pictures. One more way they can try to mess with us. And that's word problems. Okay? We should be expert at word problems right now. So first things first, our strategy is always to read it, just get a general sense of what they're asking for. Then go back, underline, circle, annotate, just like you do in English class. So Jorge rides his bike 9 miles south and then 12 miles east. How far is he from his starting point? Okay, so we got some distances here. Let's go back. So he rides his bike 9 miles south, so there we're going south and then we're going east. Well, first things first, let's make sure we know what north and south is. So north is going up, south is going back. So east is your right hand side, so east, and this is west. So this will help us out a little bit. If he rides about 9 miles south, so let's say Jorge is starting here. Hey Jorge, right here. I can't draw a bike, so let's pretend he walks. So he goes 9 miles south, boom. And then he goes 12 miles east, so he's headed south and then he's going east, so now he's going 12 miles east. Okay, well if he goes south and east, this must be a right angle here. Okay, and we want to know how far is he from his starting point. Well, if he started here and he ends here, we are going to create a triangle from this word problem. Okay, and this is our distance that we want to solve. And you got it. It's our hypotenuse. Okay, so really what we need to do is plug it into our a squared plus b squared is equal to c squared formula. We get 9 squared plus 12 squared is equal to c squared. 9 squared, that's 81, plus 12 squared, 144, is equal to c squared. All my mental mathematicians out there, you add that up and what do we get? Ooh, you got it. 225 is equal to c squared. And our last step is to take the square root of both sides. So I take the square root of 225. That's going to be equal to the square root of c squared. And that's going to get me c is equal to 15. Okay? So that's my answer. I know Jorge is 15 miles. Forgot our labels here. 15 miles from his original starting point. You have a couple practice problems in your packet. Go get to work. Go blue.